All right, welcome back to the deep dive. You know, something that low key keeps a lot of us up at night are those like really rare, this kind of unusual coding questions, the
Yeah.
ones that pop up in interviews or when you're really trying to push yourself and your coding skills, right?
Yeah, for sure.
So we're going to dive deep, right? This is the deep dive, after all, into a blog post from 2025 from the Algo Academy blog, and it's called How to Tackle Rare and Unusual Coding Questions, a comprehensive guide.
Nice.
And you should really think of this deep dive as like your secret weapon. Like next time you're faced with a real coding challenge, right?
Rightly.
Whether it's in an interview or even just for your own, personal growth as a coder.
Yeah. These are the questions that really test your ability to think beyond, just the syntax and the algorithms. They kind of force you to get creative
Okay.
and combine those concepts in new ways.
So, okay, but what does that actually look like in practice? Like, what actually makes a coding question, like, rare or unusual, right?
Yeah.
Like, what are the signs?
Well, imagine, right? Imagine being asked to design a system, like a whole system,
Okay.
for storing and retrieving data, but in 4D space.
Oh, wow.
And now this isn't about like building an actual time machine.
Right.
It's more about challenging you to really think about data structures, but in a completely different way.
Okay.
Like, how do you even represent an extra dimension?
Yeah.
Like, how would you even visualize that data,
Right.
These questions, these types of questions, they delve into concepts that are less about practical application
Gotcha.
and more about, stretching your understanding of theoretical computer science.
That's wild. I remember struggling with, like, 3D graphics in college. 4D data storage sounds like, I don't know, something out of, like, a sci-fi movie. Like, I think I would just freeze up. How do we even begin to, like, wrap our heads around something like that without, like, panicking? You know
Right.
what I mean?
It's natural to feel intimidated by it, but the key is to really approach it with a sense of curiosity, you know,
Right.
rather than fear.
Okay, yeah.
Think of it like this. If someone asks you to explain, I don't know, some complex concept to like a 5-year-old,
Mhm.
you would have to break it down into very simple terms, right?
Right, right.
That's the same approach you need here.
So it's about like simplifying,
Yeah.
like turning 4D space into something relatable, even if it's just like conceptually.
Right. Yeah.
Okay, okay. I'm starting to get it, but I'm also starting to realize that just knowing like basic sorting algorithms is probably not going to cut it here.
You're absolutely right. These questions, a lot of times they do require a broader knowledge base.
Okay.
For instance, you might be asked to implement a quantum algorithm, but using classical code.
Mhm.
Now, this kind of assumes that you have at least some understanding of what a qubit is and how it differs from like a classical bit.
To be honest, my understanding of like quantum anything is pretty limited. Is it really important to have like all this specialized knowledge for every single like type of unusual question? Where do we even begin?
Don't worry, it's not about being like a walking encyclopedia of like, all this obscure knowledge.
Yeah.
It's more about having a really solid foundation, like a really good base understanding,
Okay.
and then just being adaptable.
Gotcha.
For example, right, if you're comfortable with bit manipulation, a question involving like simulating a quantum operation with XOR, might not seem as daunting.
Okay.
You see what I mean?
Right. So it's about connecting the dots between what we already know and these seemingly like totally alien concepts, right?
Exactly.
Okay. So let's say we do get hit with one of these like mind benders, right? What's our first step? Should we just start coding randomly and just hope to the best?
Whoa, whoa, whoa. Hold your horses. One of the biggest mistakes people make is like jumping into the code before they truly understand the problem.
Okay.
Like take the 4D space example.
Hmm.
Before you even think about data structures, you need to at least try and visualize, like, what does that space even look like?
Yeah.
It's all about building those mental models first. It's not just about writing the code.
Gotcha.
And sometimes sketching it out can really help with that,
Yeah.
to build that model.
I see. So it's about translating the abstract into something more concrete, even if it's just like a crude drawing on a whiteboard.
Exactly.
But what if we're completely stuck? I mean, what if even after like breaking it down, drawing diagrams, we still have no clue where to even start?
Don't be afraid to verbalize your thought process.
Okay.
Like, talk through your understanding of the problem, even if it seems, basic.
Yeah.
This is like the thinking aloud approach, and it's valuable for a few reasons.
Okay.
First, it forces you to articulate your thoughts clearly, which can often lead to new insights that you wouldn't have had otherwise.
Gotcha.
Secondly, it helps, let's say, an interviewer understand your approach,
Hmm.
which is crucial in an interview setting.
Oh, okay. Yeah.
And sometimes just saying it out loud can help you to, catch errors in your logic.
So it's like having a built-in debugger. Exactly.
For your brain. I like that. But what if, even after all that, we're still drawing a blank? I mean, some of these questions sound like they, require years of specialized study, right?
Remember, it's perfectly acceptable to just start with what you know,
Okay.
even if you don't have a complete solution right away. Tackle the familiar aspects of the problem first. For instance, if you're given a question about pathfinding in a 4D space, start with, how you'd approach pathfinding in a 2D or 3D space. Building from that familiar ground can really give you the confidence to tackle those more unusual aspects.
Right, right. Okay.
That's a great point. It's like those classic optical illusions. Sometimes you just need to shift your perspective a little bit and boom, you see the solution.
Yeah, yeah, totally.
Mhm.
Okay, I'm feeling a little bit more confident already, but let's get down to, the brass tacks here.
Okay.
What are some, practical strategies that we can actually use when we're faced with these, unusual questions?
One powerful technique is to try and draw analogies to concepts that you're already familiar with. Okay.
Let's say you're asked about that quantum algorithm, but using classical code thing, right?
Right.
Think about it kind of like translating a language.
Okay.
Quantum computers, they have their own language, right? With qubits and superpositions, all that stuff.
Right.
And your job is to find the equivalent meaning, but in the language of classical code, using bits and more traditional operations.
So instead of freaking out about quantum physics, I can just focus on the translation process.
Exactly.
Yeah, okay, I like that. But what if even after all that I still can't crack the code? Is there a point where you just throw in the towel?
Absolutely not.
Oh,
Even
that
if you
is.
don't reach a perfect solution, the journey itself is incredibly valuable.
Okay.
Let's say you hit a roadblock with that 4D data storage problem, right?
Right.
Instead of giving up, explore why you're stuck.
Right.
You know,
Okay.
is it the data structure itself? Is it the visualization? Documenting your thought process, even the dead ends, can reveal underlying patterns that might help you with other problems down the line.
So it's about learning from the struggle, not just aiming for a perfect score every time.
Exactly.
Okay, that's a relief because honestly, some of these questions sound downright scary.
Let me share a personal anecdote.
Okay.
I once had an interview where they asked me to design an algorithm for navigating a maze, but in 5D space.
Oh, wow.
Now, I had no idea what a 5D maze even looked like, let alone how to navigate it.
Right.
I felt my palms start to sweat, but instead of panicking, I just started by asking clarifying questions.
Okay.
Could I assume that the maze was like a regular grid? Were there any obstacles? By breaking down the problem and verbalizing my assumptions, I not only bought myself some time, but I also impressed the interviewer with my methodical approach.
See, this is why I love the deep dive real world stories that we can all learn from.
Yeah.
Okay, let's be real. Sometimes even with the best strategies, we just hit a wall.
Yeah.
How do we deal with that feeling of being completely stumped, especially in a high pressure situation like an interview?
That feeling is totally normal. Even the most experienced programmers encounter problems that throw them off.
Oh, okay.
The key is to remember that the interviewer isn't necessarily looking for a perfect answer right off the bat.
Right.
They want to see your problem-solving skills in action.
Yeah. Okay.
If you're stuck, try explaining your thought process.
Yeah.
I'm thinking about using a recursive approach here because, or I'm not sure what the most efficient data structure would be, but I'm leaning towards a hash table because
You're right.
by talking it through, you're showing the interviewer that you can think critically and that you're willing to learn.
It's like we're saying, hey, I might not have all the answers right now, but I'm going to figure this out step by step.
Exactly. And, there's another benefit to working through these unusual questions, even if you don't find the ideal solution during the interview.
Oh, okay. I'm all ears, lay it on me.
It's about expanding your mental toolkit.
Okay.
Every time you encounter a new concept or try a different approach, you're adding another tool to your problem-solving arsenal. Even if that specific tool doesn't quite work for the current problem, it might be the perfect solution for a different challenge down the road.
So it's like we're building a coding Swiss Army knife ready to tackle anything that comes our way.
Precisely. And you never know where inspiration might strike.
Right.
I remember wrestling with a particularly tricky question involving bit manipulation.
Mm-hmm.
I was stuck for hours trying all sorts of approaches. And then it hit me, a technique I learned in a completely different context years ago suddenly clicked into place.
Wow. So it's not just about learning new things, it's also about making connections between seemingly unrelated concepts.
Yeah.
That's pretty cool. But for those of us who are more focused on practical skills, how do we bridge the gap between these abstract, unusual problems and real-world coding challenges?
That's an excellent question.
Yeah.
While these rare questions might not directly map to your everyday coding tasks, they train your brain to think differently. It's about developing that mental agility to approach any problem, whether it's debugging a complex system or optimizing a piece of code with a fresh perspective.
So it's not just about learning the answer to one specific question. It's about learning how to think like a problem solver, period.
Exactly. And, there's something incredibly satisfying about finally cracking the code of one of these challenging
Oh,
problems.
yeah.
It's like that aha moment when a complex concept suddenly makes sense, or when a jumbled puzzle pieces itself together.
I totally get that. It's like those moments of pure joy when you conquer a difficult level in a video game or finally solve a tricky Sudoku puzzle.
Exactly.
But let's be realistic, not everyone enjoys those mental gymnastics.
Right.
Some people might be thinking, look, I just want to build websites or write clean code for my job. I don't need to solve quantum riddles.
And that's perfectly fine. Not everyone needs to be a competitive programmer or a theoretical computer scientist.
Right.
But I would argue that even for those with more practical goals, there's value in stepping outside your comfort zone every now and then. Think of it like cross-training for your brain.
Okay.
Just like a runner might benefit from incorporating swimming or weightlifting into their routine, a programmer can benefit from tackling challenges that force them to think in new ways.
I love that analogy, cross-training for the brain. It's about keeping our minds sharp and adaptable no matter what kind of coding we do.
Precisely. And, there's a deeper connection here to learning in general.
Okay.
These unusual coding questions, with their emphasis on breaking down problems, drawing analogies, and persisting through challenges, are almost like microcosms of the learning process itself.
Whoa, now that's getting philosophical. I like it.
Think about it, when we encounter something new and challenging, whether it's a complex coding concept or a new language, we often feel overwhelmed at first.
Right.
But by applying those same problem-solving strategies we've been discussing, we can gradually break down those barriers and make the unfamiliar familiar.
That's a really powerful insight. It's like those challenges, those moments that make us go, wait, what? Are actually opportunities in disguise.
Yes.
They're chances to learn, grow, and expand our understanding of the world around us. But we've covered a lot of ground here. Before we move on, could you sum up some key takeaways for our listeners?
Of course. Firstly, remember that unusual coding questions are designed to assess your problem-solving abilities, not your ability to memorize obscure algorithms.
Right.
Embrace the challenge and view it as an opportunity to learn and grow.
And don't forget those practical strategies. Break down the problem, draw analogies, and don't be afraid to think out loud.
Absolutely. We've also talked about the importance of expanding your knowledge base, not just in terms of specific algorithms, but in terms of broader concepts and even seemingly unrelated fields.
And perhaps most importantly, we've emphasized that it's not just about finding the right answer, it's about embracing the process of learning, adapting, and growing as a coder. But hey, before we get too philosophical, let's switch gears for a bit. Coming up, we'll explore some specific types of unusual questions and share some actionable tips for tackling those tricky beasts. Stay tuned. Welcome back to the Deep Dive. We've been talking about these rare and unusual coding questions, those brain-bending challenges that can make even the most seasoned programmers, sweat a little bit.
Yeah, absolutely. They really push the boundaries of our knowledge and problem-solving skills.
And, we've talked about everything from mindset and strategies to the deeper philosophical implications of, embracing the unknown. But before we wrap up this deep dive, I want to circle back to something you mentioned earlier about these unusual questions, almost being like metaphors for life itself.
Yeah. It's a connection that really resonates deeply with me.
Mm-hmm.
Just as we encounter those head-scratching coding problems that just seem impossible at first, life throws us these curveballs.
Yeah.
And they force us to adapt, to think outside the box, to tap into our resilience.
It's like life is this giant coding challenge and we're all just trying to debug our way through it,
Yeah.
line by line.
Oh, I love that analogy.
Yeah.
And just as we break down those complex coding problems into, smaller, more manageable steps, we can apply that same principle to life's challenges too.
Right. So instead of getting overwhelmed by the sheer magnitude of a problem. We focus on what we can control, those small incremental steps that we can take to move forward.
Exactly. Whether it's learning a new skill, tackling a complex project at work, or even navigating, a difficult personal situation, breaking it down into those bite-sized pieces, it makes it feel less daunting, more achievable.
It's like that saying, the journey of 1,000 miles begins with a single step. But sometimes even when we know the steps, we stumble, we hit those roadblocks and we feel like giving up.
Yeah, and that's perfectly normal. You know, both in coding and in life, setbacks are inevitable. But it's how we respond to those setbacks that truly defines our growth.
So it's not about, avoiding failure. It's about learning from those mistakes,
Yeah.
adapting our approach, and persisting even when the going gets tough, right?
Precisely. And, one of the most rewarding aspects of, both coding and life is that the learning never truly ends. There's always a new challenge to tackle, a new problem to solve, a new skill to master.
It's what keeps things interesting, right? Like we're on this continuous journey of exploration and discovery, both in the digital realm and in the real world.
Couldn't agree more. And the beautiful thing is that the skills that we cultivate in one realm, they often translate seamlessly to the other.
So whether we're debugging a piece of code or we're navigating like a tricky interpersonal situation, those problem-solving muscles that we're building are constantly working, helping us approach those challenges with, a more analytical and adaptable mindset.
Absolutely. It's about developing that mental agility to approach any problem, whether it's technical or personal, with a sense of curiosity, creativity, and a willingness to learn.
This has been such an insightful conversation. Thank you for sharing your wisdom and insights with us today. I feel like I've not only gained some valuable coding tips, but also like a fresh perspective on approaching challenges in all aspects of life.
Well, it's been my pleasure. I always enjoy exploring the connections between these, seemingly technical concepts and the broader lessons that we can apply to our lives.
And to all our listeners out there, remember to embrace those challenges, keep learning, keep growing, and never stop exploring the fascinating world of code. Until next time, happy coding.